Hello and welcome to Algebra 2, Lesson 56. In this lesson, we're going to learn about finding the distance between 2 points. So again, we have another topic that we covered back in our Algebra 1 course. So for most of you, this lesson will just be a review. If you haven't seen this topic before, don't worry. This lesson is going to be very, very easy. This concept is something you can pick up pretty much right away. So again, the purpose of the lesson today is just to be able to figure out the distance between any 2 points on a coordinate plane. And basically the way we're going to do this is we're going to use something known as the distance formula. Now I know some of you will hear the term distance formula and you're immediately thinking about the distance formula we used with motion word problems, right? You're thinking about distance traveled equals the rate of speed times the time traveled. So this distance formula has the same name, but it performs a very different application, okay? So essentially you're going to pick one of the points and you're going to choose it to be x sub 1, y sub 1. You're going to pick another point, you're going to choose it to be x sub 2, y sub 2, and you're going to plug into this formula and it's going to spit out a distance between the 2 points. Very easy to use, but before we kind of get to that, I want you to understand where it comes from. So basically it's a direct application of the Pythagorean formula, or you could say the Pythagorean theorem. So that's the very famous a squared plus b squared equals c squared that you see on your screen. So the Pythagorean formula basically relates the lengths of the sides of a right triangle. So you might not have taken a geometry class before. In case you haven't, basically a right triangle is a triangle with a 90-degree angle. So this symbol right here tells you that you have a 90-degree angle or a right angle, which is why we call this guy a right triangle. So this is a right triangle. Okay? So when you see this symbol, you know that this formula is going to apply. So with a right triangle, we have 2 legs, which are normally labeled as A and B. Now these are going to be the 2 shorter sides of the triangle. So you see we have leg A here and leg B here. Then we have the longest side, which is always opposite of this 90-degree angle. This is known as the hypotenuse, and this is always going to be labeled as C. So essentially when we square each of the 2 legs and then sum those amounts, it's always going to be equal to the hypotenuse squared. So in other words, the measure of leg A, so from here to here, if I square that guy, that's where I get this a squared from. And then I add that to the measure of leg B, so from here to here, that guy squared, so that's where b squared comes from. This is equal to or the same as the hypotenuse or c squared, so from here to here. Okay, so that's where the c squared comes from. So a squared plus b squared equals c squared. So how can we use this to basically find out the distance between 2 points on a coordinate plane? Well, what's going to end up happening is if you know 2 of the sides, you can use this formula to find the third side, or basically what's unknown. So let's say I had a point that was here and a point that was here. So what's going to happen is I'm going to be able to find the measure of leg B and the measure of leg A. The measure of leg B will just be a horizontal distance, so from here to here. Okay, so we're going to be looking at the x values for that, and we'll talk about that in a minute when we get to the kind of example. And then the measure for leg A, that's going to be this vertical distance. So from here to here, okay, so that's going to be us looking at kind of the y values. Those are easy to find. We can easily find the value for leg B. We can easily find the value for leg A. So we can plug that into the formula and solve for the unknown, which is going to be C, the hypotenuse, or again, in this case, the distance between the 2 points. All right, so let's take a look at the example. So we have the point 5, 0 and the point -3, 6. So let's start by just plotting those. So we have 5, 0, and we have -3, 6. So if we want to plot these, let's go to 5, 0 first. So that guy, we're just going to go 5 units to the right. We're not going to move it all vertically. So this is 5, 0. So let me label that. This is 5, 0. And -3, 6. So I'm going to go 3 units to the left and 6 units up. That's going to be right there. So I'm going to call this -3, 6. So let me draw a line connecting the points. So this line right here that represents the distance between the 2 points will be C, or the hypotenuse. Now what I'm going to do to make a right triangle, I'm going to take an x value from one of the points and I'm going to take a y value from the other. So in other words, I could take 5 from this guy and 6 from this guy. So I could make a point 5, 6. That would complete my right triangle. So if I go to 5 and then up to 6, so that right there would give me a right triangle. Now, I'm not going to do it that way because I can do it another way and it's going to be easier for us to see. So I'm going to take an x value of -3 and a y value of 0. So I'm going to go to -3, 0 on the number line, which is going to be right here. So that's another way you can kind of complete that guy. So take an x value from one point and a y value from the other. That's how you can get your kind of third vertex for the right triangle. So let's kind of fill this in now. Okay, so not perfect, but you get the idea. Let me draw this symbol here real quick. So that tells us we have a 90-degree angle. Okay, so I'm just going to go ahead and label this kind of horizontal measure from here to here. I'm going to label that as B, and I'm going to label this vertical measure from here to here. I'm going to label that as A. Okay, so how can we find the measure for B and the measure for A? We know that we're going to end up solving for C, but B and A should be easy to find. So for B, what do I want? This is a horizontal line. So think about the x-axis or the x values. What is the x value here, and what is the x value here? Well, let me kind of write this point in here. This is -3, 0. So the x value here is -3, and the x value here is 5. So just think about this before we kind of do any procedure. Just think about this. If I go from -3 to 0, I've traveled 3 units. And then if I go from 0 to 5, I've traveled another 5 units. So 3 plus 5 is 8. So that tells me the distance or the measure for B is going to be 8. But we're not going to pull out a coordinate plane each time and count things. We need a better procedure. So basically, if I'm looking at this distance here, I want the difference in x values. But because we want to guard against getting a negative answer, right, because we don't want a negative distance, we can do this inside of absolute value bars. So I could say that I have the absolute value of -3, which is the x coordinate here, minus 5, which is the x coordinate there. This is equal to the absolute value of -8, which is equal to 8, which is what I got. Or you could also do it the other way. Okay, the order isn't going to matter. So you can go ahead and say that you have 5 minus a -3, which is 5 plus 3. So the absolute value of that would be the absolute value of 8, which is also 8. Okay. Now, similarly, when we look at kind of the measure of A, now I'm looking at a vertical line. So with a vertical line, I'm thinking about y values, okay, because you're thinking about this as being parallel to the y-axis. The y-axis is going up and down, okay? So now we're thinking about y values. So here I have a 6 for a y value, and here I have a 0, okay? So for those 2 points, again, from here and here. So I would do 6 minus 0 inside of absolute value bars. And that would give me the absolute value of 6, which is 6. Or I could flip that around and say the absolute value of 0 minus 6, which is the absolute value of -6, which is also 6. Again, the absolute value operation is just there to make sure that we don't get a negative distance, okay? So once we have the value for B and A, we know that we can solve for C. So let's go to a different page. So again, I'm just going to write that A squared plus B squared equals C squared. So for A, we know that this guy was 6. For B, we know this guy was 8. So if I plug in there, what's going to happen is I'm going to have 6 squared plus 8 squared is equal to C squared. Let me kind of move this up a little bit. And I'll erase this. We don't need this anymore. Kind of write that in. So 6 squared is 36 plus 8 squared is 64. This equals C squared. 36 plus 64 is 100. So you get 100 is equal to C squared. Now, we would take the square root of each side to get C by itself. So you take square root of this side. You're used to doing this. You'll say plus or minus the square root of this side. So what you're going to see in a minute is one of these solutions you could throw out, right? So you'll have plus or minus 10 is equal to C, okay? So basically C is going to be equal to plus or minus 10. Now, does it make sense for C to be equal to -10? If I go back, does it make sense for the distance from here to here to be -10? No, because the distance can't be negative. So when we do this guy, we just need the principal square root, right? We don't need to think about any negatives there because that would basically be nonsense, right? So C there, the distance between these 2 points is going to be 10. So that's going to be my distance. So if I go back, this guy right here, if I wanted to label it, I could say this is 10. We already know that B is 8, and we know that A is 6. So now that we've seen an example of this on the coordinate plane, let's make it very, very simple. So all you really need is this formula here, and I'll kind of explain where this comes from. So if you have points x sub 1, y sub 1, and x sub 2, y sub 2, you just plug into this formula and you'll find the distance between the two. So let's say we go with our original example. So we had 5, 0, and we had -3, 6, right? Those were our 2 points. So let's label this first one. Let me kind of drag this over here so it's not in the way. Let's label this first one as x sub 1, y sub 1. Let's label this second one as x sub 2, y sub 2. And again, it doesn't matter which one you label as which. Okay, you can plug in whichever one you want for either. So my distance is going to be equal to the square root of, so you have your x sub 2, which in this case is negative 3, minus your x sub 1, which is 5. This quantity is squared. Then plus, you're going to have your y sub 2, which is going to be 6, minus your y sub 1, which is going to be 0, this quantity squared. Now, before we do anything, I want you to remember where we got this from. This negative 3 minus 5 was what? This was the horizontal distance, if we go back, from right here, right? It was the difference in x values. So that's all we need to do. We take the difference in x values. Now, in this case, we did it in absolute value bars, but when we come here, we don't see absolute value bars. That's because we're squaring the result, okay? So if this was negative, when we square it, it becomes positive. If it was positive, when we square it, it stays positive, okay? So that's why you don't need absolute value bars there. So negative 3 minus 5 is negative 8. Negative 8 squared is 64. So this is 64 here. Then here, we have the difference in y values. So 6 minus 0. So if we go back up, again, that's the same thing we did here. We had a y coordinate of 6. We had a y coordinate of 0. We take the difference between the two. Again, when you do it on this, you take the absolute value, right? But when you get to the formula, you don't need the absolute value operation because, again, you're squaring it, okay? So 6 minus 0 is 6. 6 squared is 36. So at this point, we have what? We have our a squared plus our b squared. And essentially, if I erase this, I could say that d squared, which just took the place of c squared, we just relabeled it as d for distance, okay? So that's clear. We'll just kind of change this back. So if d squared is equal to, this was our b squared plus our a squared, well, what happens is to get d by itself, I just take the principal square root of each side, right? I don't need to go plus or minus because the negative solution will be thrown out. You don't want a negative distance. So at this point, we pretty much just solve. So 64 plus 36 is 100. And then the square root of 100 is 10. So d equals 10. So much, much quicker to just use the formula. But I want you to understand where it comes from so that in a pinch, if you can't remember it, you can go back through and say, okay, well, if I had, a squared plus b squared equals c squared, okay, well, I know that one of these is going to be the difference in x values. One of these is going to be the difference in y values, so on and so forth. You can derive the formula. All right, let's take a look at another example. So we have negative 6 comma 3 and negative 8 comma 2. So let's just label this as x sub 1, y sub 1. Let's label this as x sub 2, y sub 2. And what I'm going to do is just plug into the distance formula. So d is equal to the square root of, so you have your x sub 2 minus your x sub 1. So negative 8 minus a negative 6, so that's plus 6 to make that better. And this is wrapped inside of parentheses and squared. Then plus your y sub 2, which is 2, minus your y sub 1, which is 3. Again, wrapped inside of parentheses and squared. So negative 8 plus 6 is negative 2. Negative 2 squared is 4. So this is 4. 2 minus 3 is negative 1. Negative 1 squared is 1. So this is 4 plus 1 or 5. So the distance between the two is going to be the square root of 5. Okay? So the distance is the square root of 5. Let me make that a little bit better. And this basically is an irrational number. So to get an exact value, you'd leave it in this form. If you wanted to approximate it, you could punch it up on a calculator and you get about 2.24. Okay, if you wanted to approximate it. But again, if you want an exact value, go with just square root of 5. All right, let's take a look at another one. So we have negative 2 comma 4 and negative 4 comma 4. I'm just going to change the order up. And I'm going to say this first point is x sub 2, y sub 2. And I'll say the second point is x sub 1, y sub 1. Okay, so I'm going to plug into my distance formula. So the distance is equal to the square root of, so for the formula, you have x sub 2, which is negative 2, minus x sub 1, which is negative 4. So minus a negative is plus a positive. So negative 2 plus 4. This is wrapped in parentheses and squared. Then plus, we're going to have our y sub 2, which is 4, minus our y sub 1, which is negative 4. So minus a negative is plus a positive. Again, this is wrapped in parentheses and squared. So negative 2 plus 4 is 2. 2 squared is 4. So this is 4. 4 plus 4 is 8. 8 squared is 64. So if we take the sum of these two values, 4 plus 64 is going to be 68. So this is going to end up being the square root of 68. Now you can simplify this because 68 factors in a 4 times 17. So what I could say is that this is the square root of 4 times 17. Square root of 4 is 2. So I can say this is 2 times the square root of 17. All right, let's take a look at one more. So we have the distance between these 2 points. We have 3 comma negative 5 and negative 3 comma 4. So let's label this first point as x sub 1, y sub 1. Let's label this second point as x sub 2, y sub 2. So the distance between the two, again, the distance is equal to the square root of, you've got x sub 2, which is negative 3, minus x sub 1, which is 3. Okay, that's wrapped in parentheses and squared. Then plus, you've got your y sub 2, which is 4, minus your y sub 1. So minus a negative 5 would be plus 5. Again, this is wrapped in parentheses and squared. So negative 3 minus 3 is negative 6. Negative 6 squared is 36. So this is 36. And then 4 plus 5 is 9. 9 squared is 81. So 36 plus 81 is 117. So this would be the square root of 117. This can be simplified. 1 plus 1 is 2. 2 plus 7 is 9. So we know this guy's divisible by 9. It's going to end up being 13 times 9. So 13 times 9, square root of 9 is 3. So I can go ahead and write this as 3 times the square root of 13 as my answer.